Protected data should be encrypted when sent over a network and when stored in a data repository. This will minimize risk of the protected data being inadvertently released. Data that contains PII, PCI, or PHI data is encrypted to protect against information disclosure. The data grid applies two algorithms to datasets, a hashing algorithm to generate a checksum to verify integrity, and an encryption algorithm to prevent interpretation. The hash algorithm is a form of irreversible encoding. The data grid supports two hashes, MD5, which produces a hash length that is 128 bits long, and SHA-256, which produces a hash length that is 256 bits long. The level of security of a hash is determined by whether or not multiple bits in the hashed file could be changed without changing the hash. The easiest way to avoid this problem is to use two hash functions. An encryption algorithm is a form of reversible encoding. The secure socket layer encrypts data during transport over the network. To reverse the encoding, a key is needed that must be managed securely. Whoever has the key can decrypt the data. The same encryption method may be used for data stored in a repository. Ideally, protected data are encrypted before transport and remain encrypted while in the data collection. The Secure Socket Layer, SSL, is a network standard for establishing an encrypted link between two systems. A shared secret is used to enable encryption at the source and decryption at the destination. The data are encrypted before transmission over the network and decrypted on reception. Transport Layer Security, TLS, is a successor to SSL technology. This also negotiates a shared secret before transmission. The keys for encryption and decryption are based on the shared secret. Unique keys are generated for each transmission. TLS version 1.1 used MD5 SHA-1 for checks of integrity. TLS version 1.2 uses SHA-256 for checks of integrity. When should data be encrypted? How can exposure of proprietary data be minimized? Policies are needed to decide when encryption is required and where the encryption should be performed. Possible policies might restrict encryption to files that have been annotated with an access approval flag, files that have been sorted into a proprietary collection, files that are in a staging area. Should proprietary data be encrypted before deposition into the repository? This is the safest approach, but requires a shared secret with the client. Chapter 6 of the Policy Examples Workbook defines tasks related to encryption that are required for protected data. The tasks include encrypt data on transfers, encrypt data on ingestion, generate report on types of protected data assets within a collection, generate report of all security and corruption events, parse event trail for all persons accessing collections, verify that protected assets have been encrypted. Once encryption has been done, it is still necessary to verify that all protected assets are appropriately encrypted. The integrity of the files must still be checked, since an encrypted file will not be recoverable once it is corrupted. Take 7 minutes to complete exercise 89. Decide whether encryption is needed for your research collaboration. How would you organize your files to simplify application of encryption? Add metadata attributes to each file. Sort encrypted data into separate subcollections. Please load a paragraph describing your decision into the lifetime library in the subcollection class INLS 624 by the end of today's class. Please turn in homework assignment number 12 by noon on Monday of the next week. Modify a staging rule to create a file version if the file already exists in the archive. Resources include LifeLib Zone Home RWMore Rules RDA-version-file.r and LifeLib Zone Home RWMore Rules test-archive.r.